And I think we're live. Hello, everybody. Thanks for joining the session. Did everybody get lunch before they came in? Most people? All right, well, we'll try to be really exciting to keep everybody awake because I know that can be tough after lunch, listening to people talk, and we'll try to do our best to keep everybody awake. My name's David Mills. I am a technical product marketing manager, and I work on HashiCorp's Vault product. And with me today is my partner in crime, my better half, Kanish Kasani, who is a product manager also working on Vault. So the session for today, how to get dynamic with secrets management, seems kind of loaded, and it is loaded. It's loaded with a lot of interesting points to discuss and things that we want to talk about. But the first thing I want to ask is, can I see a show of hands for anybody in the room who has discovered a secret in an unsecure location or experienced similar things to that in their organization? And there's no shame, because this happened to everybody. Okay, a large number of people, and that's not surprising. So that's one thing we want to talk about today, and I'm going to start talking about some of the issues that we see around secrets management in terms of how bad things can happen and how the secrets actually get out and what kind of secrets they are. And then the next thing I want to do is talk about how to find them, because we want to discover how bad that blast radius is. And it's typically way larger than anybody thinks it is until they start scanning all of their environments where those secrets or credentials might live. So we want to discover how bad that is. We want to talk about how to remediate those, best practices for remediating them. And then at that point, I'm going to hand it over to Kanish. And Kanish is going to talk about managing secrets and different types of secrets to try and help organizations from getting into that situation to begin with. So that's just a quick review of what we're going to cover today, and hopefully that's going to be interesting. The last thing I want to say is I want to make sure that everybody in this room, and our goal is for everybody in this room to walk away with at least one piece of information that is actionable, so you can go back to your organizations and start implementing some kind of change to get rid of secrets that are sitting there forever, static, unmanaged, and causing problems, either application outages or causing breaches. So let's get started. So most breaches start with stolen credentials. That's not a surprise. The latest Verizon data breach data shows us there's been an increase of 180%. In 2024 alone, we've seen some of the biggest breaches that we've seen in history. And there's some really common elements involved here. Almost 70% of those breaches involved a human element. Big surprise. So there always seems to be a bad actor involved in this, the human element. And then almost 80% of web application breaches consisted of stolen credentials. So you put those two things together, and it's not a very good story. The average size of a breach so far in 2024 is 4.88 million. And that's not good. So we need to talk about ways that we can start to fight against this. We can start chipping away at all of those risks that pretty much every organization has sitting out in their environments for one reason or another. So there's another part of this secrets problem that is a cost as well. And it's not the cost of the breach, but it's the cost of trying to actually manage secrets effectively and doing that in a traditional way. This is just a really simple equation. It's based on some customer information that we have for a customer that took, looking at 500 secrets that they want to change, update, rotate every month. And the salary of the person who's responsible for doing that takes them about an hour per secret to do that. We're talking traditional workflows. So you have to submit a ticket. Somebody has to deal with manually updating the secret, whatever kind of secret that is. And what it comes to is for 500 secrets, you're looking at almost $500,000 a year spent doing this manually. So this is another warning sign and a reason why there are so many credentials that sit out there and end up in unsecure locations and don't get rotated very often, because it's a pain, it costs money, and it costs a lot of time. So we want to talk about ways to do this more effectively and try to chip away at static credentials in particular, and ones that don't get rotated. This is a quick look at secret categories. There's definitely more detail to this, but I think this is helpful in recognizing types of secrets that we're all using in the organizations. And it's our funnel, aka inverted pyramid. And at the top, we have the unmanaged secrets. Most of these tend to be static secrets. So key value secrets, username, password, it might be a database password and username that sits out there for a long time. That's the worst, and that's where most of the problems are being caused. The next is, you might have these secrets, they might be long-lived, but you're storing them and managing them in a secure place at least. So that could be AWS Secrets Manager, it could be HashiCorp Vault. That's a good first step in trying to keep them from getting out or being mishandled. But really, where we want to get, because it's so high risk at the top, is we want to get down to automating secrets management. And I'm talking about automatically rotating secrets, whatever kind of secret that is. And Kanishka is going to talk a little bit about the use cases where different types of secrets work best. And then dynamic secrets are those ephemeral secrets that get generated, created just in time. They might be unique for an update in a CI/CD pipeline, and it gets revoked. There's a time to live associated with it, and it's a one-time use, and it goes away. So that's really, really secure. So those are the categories of secrets we're talking about. I'm going to talk first about how to find the blast radius, how to find the ones that are at the top, how to try and remediate them. And then once we move over to Kanish, he's going to talk about doing rotating and dynamic secrets. So this is an interesting diagram. I like this diagram because it actually accurately represents the way that secrets get managed, I think, in a lot of larger organizations. And so you might have password managers that you're using for some types of secrets. You might be using AWS Secrets Manager. You might be using GitHub. And there's all kinds of workflows associated with these different tools that organizations are using to store and manage their secrets. So it's not really surprising that we end up with multiple workflows and multiple places where we're storing the secrets. And I think what we want to do is try and get away from this, because what you lose is that centralized visibility for all the secrets. And when I talk about secrets, I'm using the term very broadly. So I'm talking about user credentials, I'm talking about certificates for PKI, I'm talking about API tokens and other things, and those things are secrets. So we want to have central visibility, and we also want to be able to centrally and automatically manage them, regardless of what workflow they need to be a part of. And we can help with that. So the challenges really fall into three categories. You've got proliferation, which is what we're talking about, where there's all kinds of things and there's all kinds of reasons for why secrets end up in unsecure locations. One of the reasons is just because of development workflows, the focus is on agile practices so often. And speed is king, and you want to be able to update applications, you want to be able to innovate quickly. And oftentimes, the tools and the processes aren't in place to do that in a secure way. And so you've got the SecOps team that's providing all of these requirements for the DevOps team for how they need to manage their secrets, but they still end up being in code. They end up getting into Git history. They end up getting into all kinds of places because that's the fastest way to do it. And they don't make it easy to do the secure thing. So it's hard to do the secure thing. So what we want to do is talk about how we can find initially what that blast radius is like, figure out where all of these unsecure secrets are, because you've got to pull them in. And the next thing is to be able to prioritize those secrets and start chipping away at them, because some are critical, some may still be active, some are in locations that might be more risky than other locations. And then what we want to do going forward is prevent that from happening, because otherwise you're just going to be on a treadmill. It's great to be able to scan, to find these things, to remediate them, but if you're not doing anything on the production end, you're not doing anything on the pipeline end of it to stop it, it's just going to keep, it's going to be a vicious circle. So HCP Vault Radar is the latest Vault product that we are bringing to market. It's currently in public beta. It is free for you to use and to try out. You can sign up for a HashiCorp Cloud Platform account to try it out if you don't have one already. And I would just up front, I dare everybody to go ahead and try this, try it for free, and take a quick look at how many secrets you find that are unsecure and how many secrets that Vault finds. And what we found is if we ask somebody how many unsecure secrets they have in their environment, just sort of average size organization, they might tell you 500. And what they find out is they actually have 5,000. And so I would go ahead and apply a 10x to how many unsecure secrets you think you have and how many you have. So Vault Radar has it has hundreds of secret patterns that it can look for. It can do automated scans of cloud environments, on-premise environments, and it will give ratings to these things that it finds. It finds unsecured data, it finds secrets, and it also allows you to be able to look at the most critical secrets first, be able to have steps that you can provide to your developer team or whoever needs to remediate that problem, to walk through and remediate it in an automated way, and then actually to be able to set gates or guardrails so that when you have people submitting code, that it automatically checks for unsecure secrets or sensitive data in that code prior to committing it, and you get an alert, an immediate alert if something is found in that environment. So there's a lot of capabilities here, and I'm just going to walk down into some of the details a little bit. So Vault Radar can find secrets, and like I mentioned, that's a broad range of things. It could be passwords, keys, it can be other things that are in code that people use to access secure locations. It can also look for personally identifiable information. So PII is a big problem if that gets out, and a lot of times that's what happens in these breaches when the secrets are leaked and a bad actor comes in and accesses the data. And there's also a third category, which is non-inclusive language. So this can be language that ends up in places that could be embarrassing, erode your brand. It could cause morale problems internally for the company. And so that's another thing that Vault Radar can scan for. Today we're going to focus on the secrets part of it, but just be aware that these are other things that Vault Radar can address and help you find. In terms of the scanning capabilities, like I mentioned, Vault Radar can scan cloud resources. It can scan on-premise resources. There's a cloud portal, and that's where all the information is, and you get a dashboard, and I'm going to show you that, just kind of walk you through that in a minute to show you what kind of information you get to help you act quickly and prioritize what it finds. There's also a command line that you can a command line agent you can download locally and scan things on-premise. And there's now a hybrid agent that is available to download, and that can scan either cloud resources or it can scan things on-premise. If there's sensitivity, you have a closed network, you want to be able to scan things locally, it can do that as well. But then it can upload the metadata, it can upload the results that it finds to the dashboard, so it's all consolidated. There's a lot of sources you can see here, Git-based version control systems you can scan, AWS Parameter Store, Confluence, even Jira. And we're going to continue to add to those data sources over time as we continue to build out Vault Radar. So how does it classify the data or the events, the information that it finds? First, it can do an activeness check. So it can find the token, whatever it finds. It can figure out if it can connect with that token, and it comes back with an activeness check. So that might be one thing that Radar uses to make something it finds critical versus high or medium. And so you want to be able to have that activeness check. There's a lot of scanning tools that are out on the market. There's a problem with false positives. So a lot of times you have so many things you're scanning, it takes a long time to comb through your results and figure out what is actually something that you need to act on and what is something you can ignore. Activeness checks is one thing that Vault Radar does. The other is it's looking for high entropy. So something that's really complex, a complex string, something that has a lot of randomness, something that is likely to be a secret, that's another check that it does. And it's also looking for versions. So it's looking to tell whether something is in a current version of a file, or if it's something that's in history, it's an older version. That also helps it figure out how things get prioritized, and they pop up in the dashboard and helps you prioritize what you need to deal with first and try and remediate. So there's more things there, but those are some kind of key capabilities that Vault Radar has that helps you prioritize the results so you're not just getting a bunch of scan result noise. And that's really important. So notifications, correlation, and remediation. Once you go out and you scan and you find out how bad your blast radius is, it's really important to, number one, be able to notify somebody immediately that there is a problem. Tell them where the problem is so that they can deal with it. That allows you to hand it off to the right person to remediate it, take steps, whatever they need to do. The other thing that's interesting is we are able to index Vault. So if a customer is using Vault and they scan with Vault Radar, it will be able to tell whether a secret they found out in the wild that was mishandled is also a secret that was stored in Vault. And so that's one thing we can do, and we're actually going to add the capability to do that with more types of secret managers and stores, where you can go out and find out whether this was something that was securely stored and somebody simply took it out. So if you find something like that, you can say, hey, I need to remove this secret from the insecure location, and then I need to rotate the one that was stored in Vault for, say, we could say wherever that Vault instance is running. So that's the kind of information we can get for correlation. We have integration with the tools that you see up here, Microsoft Teams and Slack, so you can get instant notification if a new secret is found. That notification will come with a link. So let's say you get a Slack message that somebody just tried to introduce a secret into code. They tried to commit that. You will get the link and click on it. It will take you directly to the line of code and the secret where it was found. So you can see that immediately. You can figure out who owns that. Who do I need to hand this off to and tell them they need to get this problem fixed and remediate it before things get committed. We also have integration with Jira. You could have Jira configured so that events get created as soon as a scan finds a problem. And then you can start to set that up so that you have a backlog that's prioritized in Jira of events that were found. So there's lots of different ways to use these tools that you can integrate with Vault Radar to get that notification and respond more quickly. The remediation steps at this point, we have 4 common remediation workflows that are actually documented. So if you go into your events in Vault Radar, you see an issue, there will be a link to the documentation for steps to remediate that. We also provide the capability for organizations to create their own custom documentation and put that link into Vault Radar. So if you want to do things differently within your organization, you want people to follow different remediation steps or customize that, you can actually add that to Vault Radar. And you'll see things start to get more automated going forward with the remediation as well. So this is just a quick overview because I've been talking about features, pictures worth 1,000 words or a video's worth 1,000 words. And this is the dashboard where you land. And you can see that you have different repositories that are being monitored, different sources. You have priorities assigned to the events that were found, whether they're critical, whether they're high. And you can also start to look at risks by categories. So the idea here is you can quickly get a handle on the blast radius, what's in there, what you should look at first, and what you need to start fixing within your environment. And right here, we can pick the category we want to look at, and I'm going to pick secrets because that's what we're focused on, but you also have the PII in non-inclusive language. I'm clicking on a link within an event. It takes me directly to the code where the secret was found, and then I can subsequently go over to settings, and I can see there's a lot of capabilities within here. So this is where I can make those integrations with the tools that we support, Jira, Slack. I can add a new data source. I can pick to do that scan with an agent, or I can do it with a cloud scan, depending on what your use case is and your scenario is. There's also an ability to refine those searches, so you can add custom regex expressions. And I'm not going to go through the whole list of things, but you can see there's a really robust capability to customize and configure Vault Radar so it works best for your environment. So that's a quick overview. That's the dashboard. That's what your experience looks like. I want to talk a little bit more about the hybrid agent because that's a brand new release for us. It's currently supported with Git and Confluence. And like I mentioned, this is an agent that you can use to either scan on-premise environments, your on-premise network, or you can use it to scan cloud resources as well. The agents can be pooled, so you set up an agent pool, and you can scale this horizontally by adding more agents, but you create that pool initially, and that's for better performance. And I'm going to show you how that works. So in the console here, you can see where I was over in the settings. This is also where we configure the agent. So we're still configuring it in the same local place. And I'm disconnected. I don't have an agent running, but I've got the pool set up. So I've got my agent pool that I can run those in. The next thing that I want to do is I want to be able to set up a secure connection so that the agent is connected securely with HCP, with the HCP platform. And so what I've done, I'll just show you where you do this. I export these variables, and these variables are what is going to set up a secure connection with the HashiCorp Cloud Platform. I also am downloading the agent locally so that I can start that running. So I've opened my command line, and I'm just going to enter the command to start the agent, and then we'll see the connection go to green. And there you can see it running. It's really quick and easy to download it and actually get it going. And we'll see that go to green. So the next thing that I want to do is I want to add a data source. I could do on-premise or cloud. I've already got an organization in GitHub. It's called HashiDemo, so I'm going to use that for just demo purposes. And then I want to just set an environment path. I've already configured that environment path to point to my GitHub token. So I don't have to put any sensitive tokens or anything in there. I'm just using an environment variable. And then I can choose for it to scan all the repositories, or I can pick just the repositories that I want it to scan. And I'm just going to pick these 3. And when I click Finish, I can see HashiDemo is done. And there's my repositories. So the next thing I want to do is I'm going to jump over to Events, and I'm going to see what popped up. And I can see my critical stuff is at the top. I'm also going to filter by Managed by Vault, because the first thing I want to know is, did somebody leak the stuff out of Vault? So I'm going to click on the token here, and I can see that somebody did. They took a GitHub token that was in Vault. It's now in a text file, and they tried to commit that. So next, I can click on the remediation steps, and I'm taken over to the documentation to remediate an issue or an event like the one I just found. And if I jump over to the remediation steps configuration, I'll click on Edit. And this is where you can add a URL to custom documentation, however you want to set up the remediation steps within your organization. So a quick demo, but hopefully that gives you an idea of what that experience is like in using the agent. And the thing to note about that, it's very similar whether you're doing a cloud scan or you're doing an on-premise scan. Very similar, and everything comes back to that centralized console where you're getting the risk ratings and you're able to filter by different results to start figuring out which issues you need to address first. A really important part about Vault Radar and where you should use it and where a lot of the problems are is both before the CI/CD pipeline, getting things in pre-commit and pre-receive, and then also being able to pick up secrets before they get committed in the pipeline. And Vault Radar addresses both of those things. So we're leveraging pre-commit hooks. We can leverage the webhooks for pre-commit and pre-receive. And there's also pull requests for your version control systems that can be configured to either stop things, block the pull request, or deliver a warning so somebody has a chance to fix that before they actually commit it. And so this is basically where Vault Radar sits, preventing leaks within the CI/CD pipeline. If you can catch both of those things, and of course the pre-commits on the desktop, you got the pre-receive on the on-prem server side, and then here in the pipeline, you're going to cut down a large number of secrets that keep leaking out into unsecure locations. So let me just show you what that looks like really quickly. And here I am in GitHub. I've got my pre-receive repository. I've got a Vault Radar folder. And I'm a SecOps operative, and I want to be able to configure these guardrails. So I have this configured. So this is going to run every time somebody tries to commit something. So I have my script that I'm going to tell GitHub to run up there. I've got Vault Radar, which I downloaded, and then also the license to run that. And if I go into the config file, I've got it checking for activeness checks. I've set the severity that I want it to look for, and then also a couple different kinds of secrets I want it to look for. And that's important because the hook happens in like 5 seconds, and it's going to fail regardless. And so you want to be able to set some specific parameters when you run this just so that you don't have that happen. So the next thing we want to do is we go into the script. The most important line of this is just basically the last line that is saying, run the script. The other thing that we configured is we're just leveraging the hook capability here. And I've already configured the webhook here. We'll just go into Edit. And I've got my repository, and then I have the actual script that I want it to run in the path. So it's really super simple. If you've ever used the hooks before for anything, it's really simple to set up and runs that. And so I'm going to go ahead, and I've got a Java Web Token here, and I'm going to go ahead and try to commit this and just show you how Vault Radar works in this situation. Try to commit changes. And then you can see it failed. And you're going to get information on what it found. And basically, you You can see it's a Java Web Token, and all the parameters that you set for that scan have made this effective because it found it in less than 5 seconds. So pretty simple, pretty straightforward. So I know that was a lot. That was a lot to cover, and that's a really quick tour through Vault Radar. But I would encourage you, if you want to go out and try this and just see what happens with the scan, I think it might be worth it. And it's pretty valuable, even if you find 50 unsecure secrets that are sitting in those locations. So that is getting a handle on the blast radius, trying to prevent it from happening. And so at this point, I want to hand it off to Kanish Sani, and he's going to go into more about how to manage secrets more effectively.
Awesome.
The clicker's off to you.
Thanks. All right. Hey, everyone. Well, first off, I want to say we're thrilled that we're adding Vault Radar. It just improves our story that we're trying to push for security lifecycle management, where Vault has been the de facto solution to secure the secrets, but it's helping us actually discover where those secrets are and also stopping it not leaking once it's already in Vault. So jumping into how we need more secure secrets. Why? Because it is sort of like if your secrets are mostly static, they are kind of a target because hackers are watching, and it only takes one credential once it's out there, and you can ask anybody that's been breached that how important that becomes. So we want to dive in, starting with we're going to look into rotating secrets and dynamic secrets and what are the subtle differences there. And starting with rotating secrets, what they are is like they make static secrets more secure. The only information that actually changes is the identifier. For example, like a username password, the username remains static while the password rotates. You can think of it as it's suited for more auditing and compliance as well, so you can make sure they have a clear trail there. And you can think of it as like if your application, so when the first version gets created, all your application instances can pick that up and use that, while when the second version gets created, when the application requests for a secret, it's the new version that it gets wherever possible, while the other version still remains active and your applications are still up, so they're not experiencing any sort of downtime included in that. And these credentials can be shared. So just wanted to make sure that we know that. Moving on to dynamic secrets, how they're a little bit different is that they're unique to each client when it gets requested. So they're on demand, they're just in time, and they're ephemeral and short-lived, so they have a really specific time to live that's attached to each one of them. And once this time to live expires, the credential automatically gets revoked and cleaned up. So you can think of it as like if you look at this diagram over here, whenever a client requests a secret, it's a unique ID that it comes with for that specific client, and it's different for every single one of them. So you can make sure that you're managing that intent of that client getting access to that specific thing, and that's the only thing, and no two credentials are the same. Now, we can think of it as, well, this is great. This is like the prime of security. We want to make sure like everything could be dynamic, but that's not usually how it works out. It comes down to what your use cases are, how things can be different, and we want to make sure like we inform folks on like how to pick between the two, because they get conflated a lot as well. So jumping into subtle differences there on when to choose auto rotation versus dynamic. Starting with auto rotation, these are perfectly suited for long-lasting workloads where you need constant connection and you can't have frequent restarts. So you can think of it as like a static web server or like a long-lived workload that needs consistent access to the database. And for compliance purposes where like you need periodic updates, for example, PCI DSS or SOC, where you need to rotate this credential every 30 to 90 days. And talking about dynamic, these ones are more suited for really, really time-bound workloads. You can think of CI/CD pipelines, Terraform runs, where you have a really specific job to do, but also it is very time-bound. After that, you don't need that provider to have access. That can be removed. Really good for microservices where cloud infrastructure access, where the jobs, for example, for batch databases, so that you can get the access, do whatever you need to, and sort of get out of there. Also for like temporary access, so if you have a faulty system, something goes down, or like you need a hot fix and you really need to get into the system really quickly, but just for a specific amount of time to do a really specific thing, that's where these are perfect to go in and like get that, and like once you have the access, you've done your job, it gets revoked. Jumping into how, like where these are offered, like if you guys have heard of Vault, like it's the de facto solution. We have Vault Enterprise, which is a self-managed, and the Vault Dedicated option, which offers a vast ecosystem of integrations. We call them secret engines. We have about 40 plus engines that are available today, and they're policy and integrations that are configured per secret engine, and we offer them for cloud service providers, databases, LDAP, certificates. As you can see, where we have secret engines for KVV2, which is your static secrets, your databases, where you can rotate your database credentials, and also your AWS credentials, where you can grab access for those within specific secret engines. There's a new type of architecture that we're coming out with, which is HCP Vault Secrets, where the way we're calling it is integrations that are a first-class concept. What it does is it separates out your authentication from the actual configuration of your integration. So you can think of it as like if your root credentials are living at the project level, they can be shared across applications, and you don't have to set them up consistently all the time, paired with our RBAC, where you can have the separation of duties, where your platform team or InfoSec team can set those up and make it available for your team to use to make it flexible, so you only have access to the integrations that you've been given specific access to, nothing else, right? And what this does is like simplifies the management for multiple use cases. You can have syncs that live at the top, rotating secrets and dynamic secrets for multiple providers, and you can allow your teams to pick these up and like self-service whatever credential they need for that specific integration. What this does is like in the construct of applications within HCP Vault Secrets, you can think of it as this is a container, and that contains all secrets that your workload could need. And this includes static secrets, rotating secrets, and dynamic secrets. So what that enables you to do is, if you start with static secrets today and you add rotating secrets tomorrow because you realize that, yeah, there's certain credentials that we want to rotate now, you don't have to change your code because it still takes the same API call to actually grab those secrets out of there. So there was no real code changes involved to like start layering on more secure secret types. So moving on with our notable mention for our other products in the secure portfolio, which is our zero trust integration from humor and security service identity. So that includes console and boundary. So you can think of it as Vault, console, and boundary working together, where if you have a database that registers itself to console and a human or a service requests access via boundary, what it would do is we'll check if you have access for that resource, and it will go to Vault and grab that credential, and via dynamic credential injection, it will grant you access for that short time to live. But what's great about that is that it's all happening behind the scenes. That user will never, your service or user will never even see the credential that's there. So jumping into more specific with auto rotation and sync. So what you can do, this is for HCP Vault Secrets. What you can do is at the project level, you're setting up your rotating integrations. We support AWS, GCP, MongoDB, Atlas, Twilio, and Confluent today, with more coming very soon, where you can configure these rotations for 30, 60, or 90 days. So this is more of like you set this up, you set the configuration policy, and you can sort of forget about it, and like your application, all it knows is that it has a working credential. So every time it rotates, all it would know is whenever I fetch a new one, it's a working credential. The good thing about it is we're taking an approach, we're calling it the two active secret approach, where when your first version gets created, like we were showing in the diagram before, all the app instances can pick it up, but like once the second version comes up, that's your active latest version. So anytime you try to access it via any client or APIs, that's the version that gets given back to the applications, but there's just to ensure no downtime and there's a lag time for other applications to pick that secret up. What that does is like if you have applications that are not able to restart like right away, or there's some legacy applications that you can just restart at any given time, they can leverage this to actually catch up whenever they have that change window. The other thing is we allow for on-demand rotations in case of emergency. So just in case you found a secret that somebody copied and you found that in Radar, what you can do is you can kick off a rotation on demand, and what it would do is it will rotate those credentials and bump off those that version of the secret and move the other secret out and create a new version. It also integrates with HCP CLI, our Terraform provider, and Vault Secrets operator, so it's available in all client types if you want to use them. And moving on to just a quick demo of how this works. So what I'm going to do here is I have a Go application where I'm going to use a S3 bucket to pull some HTML. And what it's going to do is it's going to grab access key IDs and the secret just so I can spin up that application. So in my AWS console, I have the demo HTML and my demos bucket. So what I'm going to do is I'm going to head over to Vault Secrets here, and I'm going to create a new application. As I mentioned before, I'm going to quickly give it a name, rotating apps, and in the create new secret dropdown, I'm going to grab auto rotating secrets because that's the one that I want to create, and I want to select the AWS provider. What I'm going to do here is I'm going to create the integration, and I'm going to use OIDC, which is the more secure way to do that. I'm going to give it a integration name, and I'm going to provide the audience for the identity token that it's going to use to build a trust relationship with AWS, and the integration role, ARN, for the role that I'm going to assume. And what you can see is like seamlessly pushes you back to your secret creation page, and I'm going to give the secret a name here, and I'm going to leave the rotation frequency the same at 30 days. Active secret versions are going to be 2. That is the max that's allowed, and the IAM username that I want the keys attached to, just so there's no lateral movement. All we're doing is rotating those keys. And you can see here, like it quickly creates those secrets, and I can see there's one active version. If I pop over to AWS console, I can see there's one access key that's created, but I haven't accessed it yet. So I'm going to go over here to my local host. I can't see because I haven't run it yet. I'm going to go to my trusty HCP CLI, and I'm going to run the server. As it pulls it up, if I pop back to my browser now, and I reload the page, my HTML is there, and it's picking up the first version of the secret. So what I want to do now is I want to show the rotate now capability, where I'm going to kick off a new rotation, and what it's going to do is going to create a new version of the secret. And now if I click in there, I can see there's 2 versions that I just created a new one, and now that's the latest version that it's going to return. So talking about the 2 version approach, going back here, if I refresh it, it's still up. There's no downtime here, but it's still using the first version of the secret. Come here, there's still 2 versions. Now if I go pop back over to my CLI and I restart the application, and I give it a second, I go back to my browser, and when I update, the application is still up. There's no downtime. The application doesn't know what changed, but now it's using the second version. So now if I pop over to my console, I can see there's 2 keys, and both of them have been accessed. So what this does is it shows you like how easy it is to like pick it up, get started with it, and your applications, it makes it really seamless between rotations, and the applications don't really need to know what's happening in the background. All they know is that there's a working credential that's been given back to it. Talking about dynamic secrets, as we call it, this is the place where we send hackers' hopes to die, because there's nothing that they have. Like, if you don't have a credential, you can't leak it. That's the premise that we want to build upon it. So with this, what we're doing is we're managing intentions, not secrets. So you're giving access for a really specific thing for a really short amount of time, and it's going to be created specifically when it's requested, and no two of them are same. And it automatically creates it, uses it, and once the TTL hits, it's going to revoke that automatically. Currently, we support AWS STS credentials and GCP service account impersonated accounts. We're starting with these because these are inherently short-lived credentials where they automatically come with a time to live, and they're really short. So like their purpose is to provide short-lived access to the resources. And we also have support for dynamic creds for HCP Terraform, which we're going to talk in a little bit. So jumping into a quick demo to see how it works, like to see it in action. I'm going to pop back over to Vault Secrets. I'm going to walk over again on how this is created. It is the same, just to illustrate the point that no matter what secret you're creating, the flow still remains the same, so you don't have to learn anything new. So you're going to create a new application. I'm going to select dynamic secrets, same as I selected auto-rotating. I'm going to click on there. I'm going to select my provider as AWS. And over here, same thing. I'm going to see two options, OIDC or access keys. But you can use access keys if you want to try stuff out, but it does create the secret zero problem where now you have a long-lived credential that is highly permissive that's laying around, and you have to manage its rotation. But over here, what we can do is we're going to use OIDC to make it's secure, and there's no secret zero, so there's no credential that we have to manage separately to manage other credentials. So once that gets created, I get popped over back to the secret creation page. I'm going to give it a secret name for S3 because I want to access my S3 bucket. I'm going to give it a role ARN. That's the role that's going to be attached to each secret when it gets vented out. Once that's done, it's going to create the secret here. So what I'm going to do now is I'm going to generate the credentials, and I'm going to try to access my S3 bucket from my command line. So when I pop over here, if I try to access it now, it's going to fail because I haven't exported my credentials out yet. So now if I paste them in here, I'm going to try to do it all over again, and give it a second, and I'm going to see my DAMLs bucket just to show like how quickly I can get access as long as I have access to those secrets within the application. So jumping on here, so like the next thing that we want, the other thing that we want to talk about is the integration with HCP Terraform. So what this does is it's just-in-time access for your Terraform runs, where you're bootstrapping a trust relationship between HCP and HCP Terraform, and leveraging the OIDC federation between AWS and HCP, just so you can make sure there's no static credentials anywhere in that flow. So, and also you can do granular scoping based on Terraform run attributes, based on workspaces, projects, and run phases as well. So jumping into a quick demo for this as well. So over here, I already have a dynamic credential created. I see like I've used it a little bit before, so I want to use it just to illustrate. So I'm going to pop over to my HCP Terraform workspace. Over here, you can see I do not have any static credentials because I've removed them all. All I'm doing here is I have variables, which is starting at the top. I have the provider auth that I want to use auth for HCP provider. I have the run provider resource, so this is going to use this string to like actually get API tokens for HCP. I'm telling it to use HVS-backed AWS as the auth. Also, I'm going to give it the name and the secret where I want it to get the secret from within HVS. So just to illustrate that we don't have any static secrets in the workspaces anymore, so there's no scattered secrets around that you have no visibility into. Over here, it's showing last deployment timestamp and the access key ID. And we're going to talk about it, why we're showing that here. So I'm going to pop over to my runs, and I'm going to kick off a new run. I'm going to hit start here while it goes through the plan. I'm going to wait for it to finish. Everything looks good. Now I'm going to confirm and apply. And as this is going on, I'm going to wait, and everything looks good. My run is completed. Now if I pop over back to Vault Secrets, I can see now there's 2 active credentials that I can monitor. That's like you always have like an audit trail. And with these access key IDs, you can see that if you wanted to use it in CloudTrail, you can pop it in there just to see what exactly that credential did. And you can see over here, because the run completed, the time changed and the access key ID changed for that Terraform run when this got deployed. So this was there's a lot of information that was given around how do we do this. Like there's different types of credentials. This is all great, but the question becomes what David said before. We want to give you something actionable to actually take back, and like how do we get the conversation started for you? So what we want to do is give some information around like how you can do some like refactoring, right? Because this is a classic blank slate problem. So you want to start out, you want to get to the most secure place you want to be in, but where do we start, right? So what we want to start from is like applications and configuration. You want to understand where it runs, what the programming language is, what the framework is, just so you can understand what's the environment that you're working with. Then you have secrets inventory. This is where Radar can come in really, really handy, and this is why we're really thrilled about that, where it can get you quick started with the discovery of like where all these secrets are, right? Like what are the common types? They're static, they're rotated, what is going on in your secrets estate? And then also your runtime method, right? Like are you a Kubernetes shop? Like you can use Vault Secrets operator to start. If you're using Vault already, you can use Vault Agent to simplify your hybrid architectures, or use that to simplify the automation for your secrets workflows. If you are a cloud native shop that you're okay with multi-tenant, you can use HCP Vault Secrets to quickly onboard and use that as an on-ramp to get on Vault. Also, and use Secrets Engine's SDKs to like really get it embedded within your applications. So a lot of information that was given here. We do want to give you something to like take away with you. So there's beautiful QR codes over here. We have HCP Vault Radar. This will give you information about how Radar works, what features it has, the latest and greatest. We have the Vault documents, so you can look at all the documentations that's there, keep up with new things that we're adding in all different flavors of Vault. And we also have an app refactoring blog, so a little bit more in detail for this, where that was written by 2 of our developer advocates that came out really recently, which has 5 steps to like walk you through step by step how you can actually get started in this journey to actually get to a point of like the highest security. And then we have the SLM blog at the end, where it gives you a holistic picture of everything that's going on in our security lifecycle vision, and like how products work together and how you can implement them in your own environments to get to like the best security posture that we can help you get there. So just want to say a couple things. First of all, thank you for being here. I know it was right after lunch. Hope we kept you engaged. If you have questions, we have a ton of folks, ton of experts that are waiting to talk to you. Pop by our booth. We have great swag, and if you want a meeting and we want to talk in depth, we're ready to talk to you guys, and hope you guys enjoy the rest of your conference, and hope you guys found this useful.
Thank you.